Alright, so today we are going to work on a new topic, that is inverse of a matrix. So there are two main concepts that you need to learn. One is identity of a matrix, the other one is inverse of a matrix. So identity are of two types and inverse is also of two types. So let's say here we have a matrix, let's name it A. Let's say the matrix is 1 3 5 7. Now if I say, let's just talk about identity first for some minutes. Identity, then identity are of two types. One is additive identity, and the other one is multiplicative. No. That's because the fundamental operations in math are just two: addition and multiplication. Subtraction and division are the derived operations. They're not the fundamental operation. They are the basic operations, but not fundamental. And by fundamental I mean like the most basic operations in math are additive and addition and multiplication. Well, we'll talk about that some other time, or you could just watch my video on YouTube as well. There is a video on my channel about basic and fundamental operations. So now there are two kinds of identities. One is additive identity, the other one is called multiplicative identity. Now in matrices, the additive identity is the identity matrix. Not identity, I mean the additive identity is null matrix, and we always give it the name O, capital O, and all the elements are always zeros. That's why it's called null matrix, or sometimes it's also called zero matrix. Now beside this, let's just talk about numbers for a minute. So in numbers, let's say 5 plus 0 equals 5. Let's say minus 2 plus 0 equals 5. See, not 5, my goodness, minus 2. Minus 2 plus 0 is minus 2. So now you see, 0 is additive identity for real numbers, because when you add a real number with a 0, it results the same real number again. See, minus 2 plus 0, so it will result the minus 2 again. So this 0 does not change the identity of the addend of the number that you are adding it with. That's why the 0 is called additive identity, and the additive identity is always universal. And by universal I mean like no matter whatever the number is, it will still return that number in the answer, whether it's a positive number like 5, whether it's a negative number like minus 2, it could be a fraction, it could be a rational number, it could be decimal, whatever. You add 0 with it, that number will return again in the answer. That's for addition. Now that's for real numbers. Now for matrices, the additive identity is the null matrix, which you can see here, of any order. The null matrix, you could write it of order 1 by 2 and order 2 by 3, 2 by 2, 3 by 3, 3 by 2, 1 by 2, 2 by 1. So you could write whatever order. But if all the elements of the matrix are 0, it's called null matrix or zero matrix, and that is the additive identity. Now why is it called additive identity? So if I add these two matrices, what's going to happen? If I add these two matrices, they're going to result in the matrix A again. So let's see, what is 1 plus 0? 1. What is 3 plus 0? 3. What is 5 plus 0? 5. What is 7 plus 0? 7. So you see, this matrix, this answer, the matrix that we got in the answer is the same as matrix A. So let's write A for it. So A plus matrix O equals A again. That means that the matrix O is the additive identity. because we did the addition, and still it gave us the answer in the form of matrix A. And then there is multiplicative identity. Multiplicative identity is for multiplication in this way. Like, let's say for real numbers, so 3 times 1 is 3. Now let's say minus 10 times 1 is minus 10. So you see, no matter whatever number I multiply with 1, I get that number again, the same number again in the answer. That means for real numbers, 1 is the multiplicative identity. That the 1 doesn't change the identity of the number you are multiplying it with. Now for matrices, there is identity matrix, which is always represented by I, capital I. And for 2 by 2, it would look like this: 1 0 0 1. Now this matrix is multiplicative identity. So when you multiply this matrix with any matrix, it will result the same matrix again. So if I multiply this matrix with matrix A, the answer will be matrix A again. Just like 3 times 1 is 3 again. Now I'm leaving this for your homework. Try it. As we have done multiplication already, so multiply identity matrix with matrix A. That's your homework. Then see if the answer is A or not. Now our topic is inverse. So again, I'll write the inverse here, and then there are 2 types of inverses. One is additive inverse, and the other one is multiplicative inverse. Now additive inverse for numbers would be like this. So like, let's say we have a number 2. What do I need to add with 2? So the answer is 0. Well, the answer is simple, minus 2. What do I need to add with, let's say, minus 3 to make it 0? So the answer is 0. The answer is 3. You need to add 3 with it. So additive inverse is very simple. Whatever number is given, we just change the sign of it, sign of the number, and then you will, when you sum it up, when you add them up, you will get a 0 as a sum. So that means the additive inverse for a number is not universal. For each and every number there will be a different additive inverse. For minus 3, the additive inverse is plus 3. For plus 2, the additive inverse is minus 2. Just change the sign to get the inverse for it. Now for matrices, let's say we have the same matrix again, matrix A. So 1 3 5 7. Now additive inverse for this matrix would be minus A. So minus 1, minus 3, you just change the signs of all the elements in the matrix. Minus 7, just like that. So that's additive inverse for matrices. Now multiplicative inverse. So I'm not going to discuss it here because that's exactly what my topic is about. Well, I'll just explain the multiplicative inverse for real numbers here. That multiplicative inverse for real numbers is like this. Let's say 2 times something is 1. Let's say minus 5 times something is 1. So again, for each and every number, multiplicative inverse is also not universal. For each and every number, there will be a different multiplicative inverse. So multiplicative inverse of a number, when 2 numbers are multiplicative inverses of each other, you multiply them, the product will be always 1. If the product is not 1, that means they are not multiplicative inverses for each other. Getting it? So now for 2, the multiplicative inverse would be 1 over 2. For minus 5, the multiplicative inverse would be minus 1 over 5. So now you see 2 times 1 over 2. So 2 times 1 by 2 equals 2 by 2. Why? Because there is 2 underneath this 2. So 2 times we multiply the numerator with numerator. 2 times 1 is 2. We multiply the denominator with denominator. So 1 times 2 is 2 again. And 2 by 2 is 1. So that's true. For 2, multiplicative inverse is 1 over 2. And just like that, similarly, for minus 5, it's minus 1 over 5. And also, let me also tell you that, let's say, for 1 over 4, the multiplicative inverse would be just 4. And also, let me also tell you that for real numbers, let's say we have a fraction like 2/3. So for 2/3, the multiplicative inverse would be 3/2. And then that would result in a 1. Now let's come to the multiplicative inverse of a matrix. Here, inverse of a matrix. By this inverse of a matrix, I mean multiplicative inverse of a matrix. We write it like this: A, and then in the power we write a minus 1. That's how we represent inverse in matrices. Equals, you can't just like find it like that and there is no matrix. Like for identity matrix we have a matrix 1 0 0 1. For additive identity we have a matrix, that is 0 matrix. And for additive inverse of a matrix we just change the signs. For multiplicative inverse there is no such thing like that. Rather there is just like, consider it a kind of formula that will give you the multiplicative inverse. So adjoint of a matrix A divided by determinant of matrix A. So first we need to find adjoint of matrix A, and then determinant of it matrix A, and then divide them both. Whatever is the answer, that will be the multiplicative inverse for a matrix. Now the first thing we need to do is find the determinant. Why? Because if the determinant is 0, then it's called singular matrix, and for singular matrix there is no inverse, because if this is 0, then that's like common. It's obvious, you cannot divide anything by 0. It's undefined. That's why we need to find the determinant first. Okay, so let's get on with it. To find determinant, this is how we do it. A determinant equals the matrix is here 1 3 5 7. Now to find determinant for that, what we do is we take the product of diagonals. So take the product of this diagonal, 1 times 7, which is 7, and then minus, that's like part of the process, that minus, and then times the product of the other diagonal, 5 times 3, which is 15. So now 7 take away 15 would be 8 minus 8. So that means the determinant is not 0. That means it's a non-singular matrix. And for a non-singular matrix, yeah, inverse is possible. So now let's move on to the adjoint of a matrix. Adjoint of A. Now the matrix A, how we find the adjoint of matrix A is, for this diagonal we just change the positions of the elements. So 7 will take the position of 1 and 1 will take the position of 7. So 7 will come here, 1 will go there. And then for the other diagonal we will change the signs. So 3 will become minus 3 and 5 will become minus 5. That's how we find the adjoint. So now we have the adjoint, we have the determinant, both. Means we just now need to divide them. So A inverse equals adjoint of matrix A, which is 7, minus 3, minus 5 and 1, and then divided by minus 8. Now a matrix could not be divided by a matrix. That's not possible. That's not a defined operation in matrices. But a matrix could be divided by a number, by a real number. That's defined and it's possible. So A inverse equals, now I'm gonna divide. It's like scalar multiplication now. So in scalar multiplication, what do? We multiply a real number with each and every element of a matrix. Now here, for this division, we will divide each and every number by that -8. So 7 divided by -8 will be minus 7 over 8. Minus 3 divided by 8 will be just 3 over 8, because minus divided by minus is positive. Now minus 5 divided by 8 will be just 5 over 8. Again, because minus divided by minus is positive, and 1 divided by minus 8 would be minus 1 over 8. And no fraction could be reduced or simplified. You could just leave it like this, or you could represent them in the form of decimals, but I don't feel it necessary to, or important to write them in decimals, so I'm going to leave it here. This matrix is the additive, the multiplicative, not additive. This is the multiplicative inverse for matrix A. So that means if I multiply A with this A inverse matrix, the answer is going to be the identity matrix. Like that. It's going to give me the answer in the form of this 1 0 0 1. And now this is your homework as well. Multiply the matrix A and A inverse and see if the result is really the identity matrix. Alright, so that's how you find inverse of a matrix. That'll be all. Any question? Okay, that's fine.